Okay, solve equations with repeated factors. And I think that once we show what these look like, that this will be pretty clear. I'm going to sketch this because it'll show up more in later chapters. Basically, where the value of y would be 0 for a graphed system, that would be your roots. It's kind of where they're rooted on a graph. Now, there are multiple possibilities. If I drew a parabola up here, it would never cross this x-axis. So there might not be any solutions to something that is of this shape. The other possibility is that it is look like this. It is looking like this. In which case I would have not one, but two roots. And the third possibility in this case is that it just barely touches the x-axis, where it would have one root. But the moment you move it down slightly, then it would grow into having two. Or the moment you move it up slightly, it would go back to having none. So that is just putting a little bit of background behind the ideas. And we've looked at things in GeoGebra by this point, so hopefully that made things clear. So let's rewrite x squared minus x plus 1/4 equals 0. Now, here's where this one gets a little bit ugly. Well, there's a fraction involved. And I'm thinking to myself, this does follow that minus plus pattern of this section. And I know that 1/4, well, maybe I want to use 1/8. Or maybe I want to use 1/2. Because I'm doubling 4, or I'm having halving, halving that, to make this happen. So let's just see what happens if I try the first incorrect one. So here's x minus 1/8 squared, which means that would be x minus 1/8 times x minus 1/8, and then I get x squared minus 2 times 1/8, which would be 1/4 x minus plus 16. So it looked like that was the wrong assumption, and that's why I started by writing it in red. Let me get all this out of the way. So, what if the correct assumption instead was x minus 1/2 squared equals 0? And then if I were to distribute that out, it would be x squared minus 1/2x minus 1/2x, which would be a whole, plus 1/4. Now, that's my way of doing it, but keep in mind that if you treated it like a was x and b was 1/2, then 2 times x times 1/2, the twos would cancel out and you'd be left with just x. If that thought and that concept is still elusive and hard to grasp and out of your reach, then let's do a handful of these together one-on-one to fix that. Now, since this is squared, that means that it's x minus 1/2 times x minus 1/2 equals 0. And then if I were to bother solving these separately, both of them would end up being repeated factors of x equals 1/2. So this means that, the roots are both 1/2, so you only have the one single root showing up here. And that's what they mean by repeated factors. It's all about this squared. See if you can do 2 on your own, because I'm going to go ahead and throw the answer up in a few seconds. So this was the whole perfect square deal, and both roots would be -6. And it would be the same. So if this were graphed and this was y equals 0, it means that just at -6, here's -5, we would have one thing running into here. In the next section, you'll be able to graph all these, and hopefully it'll enrich the understanding of this chapter as well. But factoring is the appropriate lead-in to quadratics, which is coming next. Now, this looks hideous, so I'll go ahead and walk through this one. Here's 3, which is y squared minus 4/3 y plus 4/9. Now notice that when I'm doing these, I'm not rewriting the a squared minus 2ab plus b squared equation every time. But for this one I will, just to show those extra steps if I wanted to. Okay, this means that y is my a. It means that b is the square root of 4/9, which is 2/3. I can visualize 2/3 being multiplied by itself to give me 4/9. And then 2ab would be 2 times y times 2/3. And when I'd multiply that out, I'd get 4/3 y, which is exactly what we're looking for. So when I factor this, with the right side being set equal to 0, I will write y minus 2/3 equals 0. And then just like all the other ones, there's that squared there. Let me make that stand out in blue just so you can see that it's not the same as this fraction. It's getting a little bit sloppy. And I'm going to have y equals 2/3 as my repeated factors. The square root property is the next thing. And what this says is that for any number n greater than 0, so notice that these are non-negatives. I've kind of just in passing mentioned how I is equal to the square root of -1. That's why they limit us on these. They want to make sure that we're only dealing with positive values for n. So if I want to figure out what x would be in something like this, I would have to treat it like the plus or minus the square root of that number. And I think it's more clear if we just use this example on the right. So square root both sides, and then below there write x equals positive or -3. And that means that 3 times 3 would give me 9. But so would -3 times -3 to get positive 9. So that's why you get this positive-negative deal going on. And when we write that out, it is way more common to write the plus up top, because there will be equations where maybe you do negative plus, but that's because formulaically this is going to be the default, whereas the plus would be the less common solution. But when we're just describing what something is equivalent to, it is always going to be plus or minus 3. We would never say minus or plus 3. It's just not the common way that we talk about these things. So this is probably something you're not uncomfortable with, and that's probably telling you that they're going to take it to a different level. So they want us to look at this word problem first. Pause this if my reading of it doesn't give you enough time to process it. During an experiment, a ball is dropped from a height of 205 feet. The formula h equals -16t squared plus h sub 0. Whenever we have sub notation, that's with the word sub because it literally means below. We write it below there because sometimes you're going to want to tell a first value of x apart from a second value of x. So x sub 1, x sub 2. Otherwise, these guys would be the same exact deal. Think about quiz averages or something. If I wanted to take all the different quiz averages, maybe the first student's was x sub 1, the second was x2, and then x sub 3. And if I added them together to get the average, that's how I might write it out. Physical science. During an experiment, a ball is dropped from a height of 205 feet. The formula h is equal to -16 squared plus h sub 0 can be used to approximate, to get close to, right, the number of seconds t it takes for the ball to reach height h from an initial height h sub 0 in feet. Find the time it takes the ball to reach the ground. Okay, I'm hearing that it's a lot of baloney, and I'm just going to write the formula out. H is equal to -16t squared plus h sub 0. I always like to rewrite it even if it gets real easy, and the reason is because it's always good to repeat the writing of formulas. So now I can plug in the initial height that it was dropped from. But here's where they're trying to trip us up a little bit. It takes for the ball to reach height h. Then it says find the time that it takes the ball to hit the ground. So here's 205 feet. When the ball hits the ground, what is its new height? Well, that's where h would be 0. So now go back and erase this value and replace it with a 0. Okay, I look at this and I'm saying, well, I could subtract 205, but I think that I'd rather add 16t squared because it means I could avoid having any negatives in front of these numbers. So on the left side, I have 16t squared is equal to 205. Now, it's weird because in this whole chapter, it's all been about factoring and all that kind of stuff, and here I'm actually steering clear of factoring. I imagine that can be a little bit confusing. Probably also a little frustrating because it's like, well, shoot, what am I going to choose to do now? Now, let's divide both sides by 16, and I will be left with t squared equals, don't use a calculator yet, and I say that because if you use a calculator now, you'll have to round. And since we still have another step of square rooting both sides, if I go into my calculator, and now I take the square root of that, that's going to make it way, way, way more accurate. So I'm going to write t is approximately positive or negative 3.6 seconds. And then we revisit the word problem. Does it make sense to have a negative value? No. So I'll erase the negative and I'll leave it with a positive value. And here's how you're going to tell these problems apart from other ones, factoring ones. We only had t squared. We did not have t squared plus t, so we weren't forced to factor on this problem if we didn't want to. I'm going to stop the video here before we move into these other solving problems.